Okay, the first thing I want to do with you today is a Punnett square review over both the one-factor crosses and the two-factor crosses. What I've done is just taken one problem from each of your assignments to go over with you. Please make sure that you pay attention to this and pay attention to the terminology as we go through. This is a problem I was seeing showing up on your worksheets. Okay, so let's just get going here. Let's do a one-factor cross first. In a one-factor cross, we're dealing with one trait at a time, so you're going to have a Punnett square consisting of 4 boxes. Now we're going to follow the same steps as you did previously. The first thing, obviously, is we need a problem. The one I chose to do here was this one from your worksheet. It says a homozygous dominant brown mouse is crossed with a heterozygous brown mouse. Tan is the recessive color. Now, 2 terms here showing up that some of you are struggling with, and that is homozygous and heterozygous. Homozygous means that the 2 alleles are identical. You can be pure dominant homozygous. That means that you would have 2 dominant alleles or a genotype with 2 capital letters, or you can be homozygous recessive, which means that you have 2 recessive alleles or a genotype with 2 lowercase letters. Heterozygous, on the other hand, means you have 1 dominant allele and 1 recessive allele. So the genotype is going to be a capital letter and a lowercase letter together. Now, the first step was to identify your alleles. It says here that brown is dominant, so a big B or a capital B stands for brown. The lowercase b is going to stand for the recessive trait then, and in this case that is a tan coat color. The second step was to identify the genotypes of the 2 mice. The first mouse is homozygous. Again, homozygous means the alleles are the same, and it is brown, brown being capital B, so the first mouse has to be big B, big B. The second mouse is heterozygous. Heterozygous means you have 1 dominant allele, 1 recessive allele, so the second mouse has to have a genotype of big B, little b. Okay, from there we make our Punnett square. Again, since we're doing a one-factor cross, this Punnett square will consist of 4 boxes. We're now going to apply Mendel's principles of segregation. And we're going to take the first genotype and separate the 2 big B's across the top. So we get a big B over each column. We're going to do the same thing for the second mouse on the left-hand side. So the big B on the top row, little b on the bottom row. From there, it's just a matter of finding the possible genotypes of the offspring. So we'll have a big B come down and a little b come across for this top left one. We go to the top right, we have a big B come down and a small b come across. Now if we do the bottom row, we're going to bid a big B down, a small b across in both of those boxes. So from here, we have to look at your genotypes and phenotypes. Do genotypes first. There are always 3 possibilities. It can be pure or homozygous dominant. It can be heterozygous, or it can be homozygous recessive. If we look back at the Punnett square, we'll see there are 2 of them that are homozygous dominant. Okay, so 2 out of our 4 gives us a 50% chance of having a homozygous dominant genotype in the offspring. We'll also see that 2 of them have the heterozygous genotype, so again that is 50%. The third genotype, the homozygous recessive, is not possible in this cross. We have 0, so that is 0%. Again, very important you pay attention to homozygous and heterozygous. Now let's move on. Let's go on to our phenotypes. Again, there are only 2 phenotypes. It's either brown or tan. Again, brown being dominant, tan being recessive. Since brown is dominant and we are dealing with Mendel's principle of complete dominance, where anytime there is a dominant gene, the dominant trait shows up. All 4 of the genotypes of the offspring have a big B, so therefore they have to be brown. So there is a 100% chance of getting brown mice from this cross. Okay, tan is not possible. Now let's look at your two-factor cross. As you can see here that we're dealing now with a Punnett square consisting of 16 boxes. Our problem says that we have red flower color being dominant over white and tall plants being dominant over short plants. Okay, so the first thing I need to do is set up my alleles. So since red is dominant, I chose a big R for red, a small r for white. Since a tall is dominant over short, a big T for tall and a small t for short. Now we have to do the genotypes again of the parent plants or the parental generation. It says that the first tall red flower plant is heterozygous for both traits. Again, there's that term heterozygous, one capital letter, one lowercase letter. And we do this for both traits. Remember, in a two-factor cross, you're going to have 4 alleles together. So for plant 1, we have a big R, little r, heterozygous for flower color. And big T, little t, heterozygous for stem length. It's heterozygous for both traits. The second plant is short with white flowers. Both of those are recessive traits. We learned earlier the only way to have a recessive trait using Mendel's laws is to have only recessive alleles. Okay, so to have white flowers, it must have 2 little r's, and to be short-stemmed, it must have 2 little t's. Now, again, we take this first genotype, we go through the law of segregation, and this big R separates from this little r, this big T separates from this little t. Now, we're also going to throw in here independent assortment, okay, which is another one of Mendel's principles or laws. So the big R could go with the big T. The big R could also go with the little t because the T's and the R's segregate independently of one another. Then we have to take care of the little r. It could go with the big T or it could go with the little t. Now if we do the next one, we take that first little r and we can go with both the little t's. We can take the second little r and go with both the little t's. So no matter how you do this, the only allele combination possible in the gametes of the second plant is a little r and a little t. Now we'll work across this top row, put the r's back together, the t's back together. We get a big R, big T, little t. Again, put your R's and T's back together. Again, very important that you're putting the R's and the T's back together. It'll make it easier at the end to make your predictions. Time we get to this third box, we have 2 little R's together with a big T, little t. And in the last box, we have only recessive alleles. Now, since row number 2 has this same allele combination as row number 1, it is only logical then that we should get the same results in row 2 that we had in row 1. And you'll see if you go through and combine your letters, you'll do that. And this will continue all the way down. So we end up with a Punnett square looking like this. Now there you can see a lot of different, or actually you'll see there's 4 different possible genotypes. I'm not as worried about genotypes as I am phenotypes. What are the possible phenotypes of the offspring? What's the possibility that they will come up? Now again, in two-factor crosses, there's always going to be 4 phenotypes. You can have both dominant traits, red and tall. You can have the dominant red with the recessive short. You can have the recessive white flower color with the tall dominant stem, or you can have both recessive traits. You can see all 4 in this column have a big R and a big T, so therefore they're going to show both dominant traits. We go to the second column, there are no capital T's, so these are going to be short with red flowers. We go to the third one, these are all going to have white flowers, but are going to be on tall stems. And back when we get to this fourth column, you'll see we have 4 that have both recessive traits, white flowers with short stems. So all four phenotypes are possible and they're equal in equal amounts. We just have to convert those to percentages. 4 out of 16 means there's a 25% chance of getting any of the phenotypes. Okay, so again, I've been grading your papers as I was going through this. Again, pay attention, heterozygous and homozygous. Again, I sent things back to you telling some of you to redo this and pay attention to those two terms. Make sure you look over your worksheets. Make sure that you redo those and get them back into me. You're going to now do your worksheet over applying Mendel's principles. This worksheet is from the book. It's pages 313 to 318. Once you complete that, don't forget to submit that. Okay. And then the next lesson, okay, you are going to be taking a quiz over Mendel, his work, his principles, and Punnett squares. Okay, again, his work, his principles, and Punnett squares.